Hi everyone, welcome to my front room for this physics experiment. So we're still doing simple harmonic motion, but we're not doing pendulums, we're doing the spring mass system. So I've come in here because I found this window handle that I've attached my spring mass system to. I'll zoom in on that in a second. I guess I should go through some other ideas of what you could attach it to if you haven't got that sort of window handle that's at a kind of appropriate height. So as I was walking around the house, I saw, I've got some hooks that are screwed into some things. Potentially, again, you could literally just stick it to something like a door frame or even a door handle probably. You could even loop the spring over the brake of a bike. If you've just got a bike, just do that. I thought about putting it, take a hanging basket down, put it where the hanging basket was, anything like that. That's the kind of thing. We're just trying to attach the spring somewhere ready to do an experiment. So we're going to do an experiment to find the spring constant of this spring using simple harmonic motion. But actually, we're not going to know if we're right or not because we don't know the spring constant of the spring. So we're going to do two experiments in one. We're going to do a simple Hooke's law experiment like we did in probably year 8 and year 9. And then we're going to find the spring constant from that. And then we're going to compare it to the spring constant that you get from a simple harmonic motion spring mass system kind of oscillation experiment. So I'll just show you my setup, I guess, in more detail. Please ask the person whose window it is before you gaffer tape a tape measure to it. That's what I've done here. I've got no worries that the window is going to be sticky or anything, but it's my window. So if you are going to do something like that, please ask somebody. I've just hooked the spring over the window handle here, and I've taped the tape measure up so that when I stand in a certain place, I know where that is so that I don't get a parallax error. So that I'm level with it actually, so that I don't get parallax error. It reads 0 at the bottom of the spring, and then I can just read off the length on the tape measure there for my Hooke's law experiment, which is what we're going to do first. But you don't have to do that. You can just measure the length with the tape measure, put the mass on, measure the new length, and then do a simple subtraction to find the extension. We're going to plot a graph of force against extension, find the gradient. The gradient should be the spring constant. We're breaking the rules really because we're changing the force on this hanger. So we should really plot a graph of extension against force, but that would be a bit inconvenient for us because then the gradient would be 1 over the spring constant. You can do it like that if you want, but it's just easier for us to do force against extension. And so, yeah, it's a simple Hooke's law experiment really. Just going to add mass, go up in 50 grams each time, read off the extension, plot a graph of force against extension, find the spring constant. That's our first experiment.